Hello, Michael here with another Renderman tutorial. Today I'm going to be talking about the different Pixar lights that come with Renderman 21. There's been some minor changes compared to 20, so I just wanted to quickly go through them and show you how to get your light set up in your scene. First off, sorry about my voice. I've been sick this week, so I might sound a little bit weird, but that aside, let's get going. So you can see I've just done a real quick render here on the left with our guy on the right in Maya. This scene has just got a plane and it's got our robot sitting there with no lights in the scene at the moment. So if you want to add a light in on your Renderman shelf, you select this button here by right clicking, and let's start with the PxrRectLight. And I'm just going to move that. Let's take a quick IPR and see what that looks like. Alright, doesn't look like much. Maybe the light intensity is much too low. Let's change it to 10. There we go. So the light intensity is on a real gradual scale as opposed to what it felt like in 20. This is because I've added in an intensity node and an exposure node. It used to just be the exposure node, and actually this way is kind of better. You kind of want to use these two in tandem with each other. For this scene, I'd probably hit the intensity at about 25 and the exposure at about 1. Usually your exposure range is going to be pretty low. If you increase it too much, it's going to blow your scene out. So think of intensity like sort of like the wattage of the light. So like if you had a light at home and you had a 25 watt light, it wouldn't be very bright, but if you had a 100 watt light, it would be a lot brighter. Exposure, if you set it to 1, it's going to complement your intensity pretty evenly. If you increase it, say to 5, you can see it starts to blow out the highlights in the scene. So an easy way to sort of think about exposure is it's really increasing the white point of the light, especially if you're using a white light. So another way to look at this, if I change this light to be blue and I increase the exposure a lot, it basically pushes all the values of the light to be as close to this color as possible. So it doesn't look very good though. Generally an exposure of about 1 is going to do the trick depending on the intensity of your light color. So with just a standard white light, exposure 1 and then your intensity is what I'd use to control the overall brightness of the light. And then you could do some incremental changes to like if you want to really push your highlights, then you could use the exposure to push those a little bit better. But for the rest of this tutorial on this particular light, let's leave the intensity at 25 and the exposure at 1. So color, I always sort of touched on that. It's very simple. You just select a color and it'll work sort of like a gel over the light. So it will change the color of the light to be whatever color you select. Default being white. Color maps. So if you want to apply a texture to your color to your light, so generally you'd use an HDR image. I'll see if I can find an image really quickly to show this. Okay, so I've got an HDR image applied to that light now. You'll see it hasn't made a huge change because essentially it's just got the image in the light, and I can show you that if I grab the visibility and turn that on. So now the camera will see the light if I point the camera at it. So you can only barely see some of the texture because of the intensity of the light, but essentially it's mapped an image to our light, and then it's projecting the colors and light intensity of that image into our scene. This can be useful, say for instance, if you're wanting to simulate the light being cast indoors from a window. So maybe you took a photo of a window and then applied that to your light. You could use that to simulate the colors being transmitted through the window. Generally that's not what I would sort of do in that situation. I'd probably use a environment light with an HDR image on it, and then use a portal or something like that. But just sort of as a real simple example. If you want to clear your color map, you can just select the reference and delete it, and then it will just go back to your color. So if you enable temperature, this is going to sort of override your color. Temperature works in kelvins. It's a scale of sort of light color. If you go below 6500, you'll get a warmer color. So say 3200 will give you a sort of warmish orange color. and if you went to say 10,000, you get a bluish color. This can be a pretty nice subtle way to affect your light color balance as opposed to using your color profile or a color map. The next lobe is refine. So emission focus, basically if you increase this, it's sort of going to act like a spotlight. So it's going to focus the light being projected to a smaller area, and you can see this already looks like a spotlight just by increasing it to 20. Actually, if I go back to your emission focus tint is going to, if you do that, the outer edges of the fall off are going to be tinted whatever color you select. So you can see that the inner part is still white, but the outer part is being tinted that blue color. Black is the default though, so black just means off. Specular amount, it's going to control the specular contribution of your light. So if you have it off, you won't see any specular reflections. This model doesn't have a whole lot of specularity, but I can show you how much it does actually have if I turn off diffuse. So if I turn specular all the way back up and turn diffuse off and zoom in somewhat, there we go. So I just had to increase the exposure to show this. So now all that's being rendered is the specular contribution of that light, as there is no diffuse being added. Intensity near distance. So basically, if I stop that IPR, if I bring this light to be close to our model. So if I take a render with our light right next to his face, you can see that his face is sort of a little bit blown out. It's not super bad, but actually, what if I increase the exposure to 2? Okay, so you can see those highlights are starting to get a bit hot. You can use the intensity near distance to scale that back, so it'll stop the hot points from sort of occurring where the light is closest to any geometry. So that's sort of just a nice refining feature. All right, and let's change that emission focus to be back down. Cone angle, this is sort of going to make your light sort of work like a spotlight. So if I change the cone angle to 45 degrees, you'll see that it's got sort of a 45-degree taper coming out from the light source. It's also hardened the edges quite a lot. So you can soften that by using the cone softness. This works in very small degrees. So if you hit it 1, you'll see that it softened the edges quite a lot. So you might want to work in sort of point increments, so like 0.25. If you went to 2, it's going to soften it way too much, but you know, maybe that's what you're going for. So the default is 0 though. I'm going to change that cone angle back to 90. So light profiles are if you've got an IES profile saved on your system. I have a couple from the big Renderman library that was released with Renderman 20, which I will show you now. So these light profiles are still available, I believe, from the big Renderman library, which you can download from Pixar's website. And I've got a tutorial on how you would possibly want to install that on your system, so you can check that out in my other tutorial videos. But essentially, what it does is it gives your light a variation in intensity. So if you look at this preview image on the right hand side, you can see that a bollard, which is a real type of light, it's got this sort of light function occurring, and you'll get a bunch of different types of shapes depending on which one you choose. So the bollard's a pretty standard light, so let's just use that and then do an IPR and you'll see what happens. Well, the first thing that happens is it gets really blown out. So let's go back to our basic settings and change that to 1.0, which will probably do it. If I zoom out, you can see actually the way that light shape has now been changed. So those can be fun to play with especially if you're trying to emulate studio environments. That can be quite useful. And the profile scale is simply the size of the IES profile. So if you made it smaller, it would be a lot smaller in the light, and larger, it would be a lot larger, obviously. Shadows are very straightforward. If I just take an IPR again and go back to our previous settings. So with shadows enabled, any geometry will cast a shadow. If you turn it off, you can see that no shadows are being cast by this particular light. Shadow color just means any shadow being cast by this light will be whatever color you choose. So if I choose blue, it will be blue. If I choose red, it will be red, etc. black obviously would be your default. Shadow max distance just controls the distance in which the shadow is being cast. A value of -1 means it's off. If we change it to say 0.1, you'll see that it's basically got no shadow. So yes, a value of maybe 2 will give you a short little shadow. So let's keep that at -1 for now. Shadow fall off just controls the fall off, or sort of the way that the light gradiates away in the shadow. So -1 is off, 1 is on, and you can see that that's softened quite a lot to the edge. See if I can get a more extreme example. Yeah, so at a value at 0.01, you can see that it's graduating a lot quicker away, but your standard setting will be -1, which is off. Actually, I'll turn that back on for a second so I can show you the gamma. So if I turn down the gamma, you can see that it basically darkens your shadows regardless of what your fall off is. And if I turn it back to 1, is going to be your standard default setting. Trace subset and don't trace subset are only going to be used if you're wanting to specify geometry to be considered for ray tracing shadows. Generally, you're probably not going to be doing this, and it's a slightly easier way of doing it would be using light linking, which I'll show you towards the end of the video. So generally, you're probably not going to, if you're starting out, you're not going to be worried about that. And finally, you've got advanced. Normalize is actually probably one of the more useful things that you've got in your settings. So if you turn on normalize, start an IPR, you'll see that nothing's really changed. If I stop that IPR and grab our light and increase its size, you'll see that the light intensity hasn't actually changed, but obviously the light being bigger has softened the shadows quite a lot because the light's reaching around behind our object. So that's useful to keep in mind if you're wanting to change the sizes of your lights but keep the intensity the same. That's useful. If I turn off normalize, you'll see that that scene gets blown out now. And another thing that's worth pointing out is if I make this light incredibly small, a good way of controlling the sharpness of your shadows is to change the size of your light. So with normalize, you'll be able to retain your value of your light without having to increase it while you make your light smaller. So if you want more detailed shadows or sharper shadow edges, what you want to do is actually use a smaller light source and probably normalize it. Trace light paths, if you use this, it will basically disable any of your shadow options and consider this light physical based rendering light, so it's simulating real world lighting. Generally, you're probably just going to keep this off if you're wanting to play with your shadow profiles and stuff. I think the more intuitive way to use these lights is with it off if you're wanting to affect your shadows slightly, but generally you're probably not going to even be worrying about these shadows too much. With thin shadows enabled, if you've got something like a glass object where light's being refracted through it, it will simulate the use of caustics rather than actually transmitting them, which will save your render time overall, but obviously will not be as realistic render. Generally, this is kept on by default. It's not too bad as a replacement for actually using real physical based rendering caustics. So generally I'd recommend it on until you're getting a little into some more advanced lighting scenarios. Light samples will override the amount of samples that are being taken from your scene render default. So I think I've got this set to 64 samples. If I change the light samples for this one light, which is the only light in the scene, to 16 and take a new IPR, you'll see that it's a lot noisier because it's a lower sample rate on that render. So you could have separate sample rates per light. You might want to increase the sample rate for particular lights if you're trying to get around some noise that's been created by specific lights. Otherwise, you just keep this set to 0, which means it is off. Light groups is for if you've got groups for specific render passes. Generally, you're not going to be using this. If you're a compositor, this is probably going to be more up your alley. But for most people, you will not be changing this. Importance multiplier you will be using if you want to assign more samples to a light over another light in your scene. So imagine if I had two lights set here. One, if I gave it an importance of 1.0, that would be sampled to the highest sample rate set by the scene. If I had another one set to 0.5, for example, it would take that that sample rate as a lot less, which might introduce some noise, but it will speed up your render time if you've got one light that you think is more important than others. So possibly if you've got some lights in the distance of your scene that aren't really contributing visually that much to the scene, but you are wanting them to cast shadows specifically for some smaller objects or something like that, that's where you might use this. But otherwise, if you've got every light set to 1, it will just take a standard render sample from each light. Light filters will be if you're using blockers. I'll do a separate tutorial for blockers, so don't worry about that one for now. And visibility is just whether or not you can see the light in the scene. So if I point the camera at the light once again, you'll see that white square. If I turn that off and restart the IPR, the light will not be visible in the render. So generally you'd want to keep it off unless you're trying to make your light look like a physical light in scene. Alright, I'm just going to very quickly drop in a couple of other lights. All the settings are basically the same on all of them. A PxrDiskLight is basically just like a rectangle light. It works a little bit better as a spotlight. They've actually removed the spotlight function, which is kind of a bit disappointing because the previous spotlight was very easy to read in the scene because it had actual physical shutters and things, whereas the new one, as you can see if I just change these settings to what they were, it doesn't have any of those settings for spotlights. But as every light can now be used as a spotlight, it's kind of, you lose some options, but you gain others by having spotlights available for square lights and things like that. So this works a little bit better as a spotlight, like I was saying. If I render that, and I change my cone angle to say 50 degrees, so I'll get a nice round circular spotlight, and then I can just change my softness to get a fairly realistic looking spotlight. So this as a spotlight isn't too bad compared to what it was before, but you will be taking more IPRs, I think, because you won't be able to visualize it easy within the Maya viewport. Otherwise, all the other settings on the disk light are the same as they are for the rectangular light, so I'm going to hide that one now, and let's drop in a PxrDiskLight. Now, the PxrDiskLight, it does not matter where you place it in your scene because light's not technically being emitted from it. It is being emitted from the distance, as if you were simulating a sky or something like that. So if I put it here, for instance, and take a render, you'll see that it appears as though there is a light somewhere in the distance. If I move it, and restart that IPR, you'll see that nothing's actually changed. That's because all the light rays are being transmitted parallel in the scene, so it's not actually simulating a real light source, or if it is, it's so far away that it doesn't matter. You'll see the intensity multiplier is incredibly high. That's because it starts off as though it is simulating a daylight light, for example. So your intensity and exposure you should already be familiar with from me talking about the disk and the rectangle light. Angle extent is basically what you're going to use to control your shadow softness. So by increasing this number, the default is 0.53. If we increase it to 5, you'll see that it's blown out quite a lot because the angle of the sun is a lot wider, and because of its intensity, it's going to create a lot more light in the scene. So if we change it to something like 1, it's slightly difficult to see, but the edges of the shadows are actually softening slightly. You'd want to balance this out with your intensity. So if I change that to 25,000, for example, so you can see with a low intensity, but with a high angle, it's softening those shadows quite a bit, and you can go a lot higher, obviously, and get a much softer much softer shadows, but you're going to have to lower your intensity quite significantly. So at a value of like maybe 50, yeah, we're starting to get somewhere. And you want to start sort of balancing this out with some possible other lights in your scene as well. So with a wide angle of 10 degrees, you get much softer shadows, but you have to reduce your intensity quite a lot. Most of the other settings are the same as they are for the other lights. So your emission focus will do the same thing. It will almost create a spotlight. However, it's a bit unwieldy to use, I find, with the distant light. So if we just increase that to a value of 5, obviously you're getting a lot less light in the scene, but theoretically it's reducing the spread of the light in your scene. Generally I wouldn't use this. I don't think it's a very intuitive way of controlling the light in your scene. So let's delete that light and let's drop in the final one that we're going to look at, which is the PxrSphere So basically this creates a sphere which will emit light. This can be good for illuminating sort of areas because it's going to transmit light in all directions. So let's use our previous values. And if I just rotate the camera around, you'll see that the light isn't visible. We can make our light visible though by going to visibility and camera visibility. If I restart that IPR, it will update. And this light works the same as all your other light settings. The only thing that you would change is really the size. You can only change the light size on the XYZ axis evenly, so you can't make its Y value more than its X and Z axis or anything like that. Because if you update that IPR, you'll see, as I've done that on the Y axis, it hasn't actually stretched it in the scene. It doesn't respond to that. It'll only respond to the average height now between those two. Okay, and finally I'm going to just show you some real simple light linking which we can use to illuminate specific objects in our scene with specific lights. So if you go to Windows, Relationship Editors, Light Linking, I'm going to do this object centric. So if we select the polycube 1 and we deselect our PxrRectLight, you'll see it's not illuminating that light anymore. It's actually still receiving some light from the plane, which is bouncing light onto it. So if you wanted to go even further, you could turn the plane off and you'll see that the plane and the cube are now not visible because the only light in the scene is not illuminating them. The plane is just barely visible here though because of the reflection of the light being cast from our robot, and this is just so it continues to simulate physical based rendering even when object centric light linking is on. So that's pretty much all there is to that. So if you're trying to set up a complex scene with multiple lights and you've got lights set up for specific objects and you don't want them affecting the world around, this is the way you'd want to do that. And that pretty much does it for this tutorial. Thank you very much for watching. If you've enjoyed the video and you found it useful, make sure you click the like button so other people can find it on YouTube easily. And if you haven't already, make sure you're subscribed because I'm doing at least one new video each week, possibly 2, possibly more. So yeah, thanks for watching and happy rendering.